All right, we're back with another reaction. I just saw this floating around on the YouTubes. This is Scott Aaronson. Let's see, this is from the Institute of Art and Ideas. OpenAI expert Scott Aaronson on consciousness, quantum physics, and AI safety. So I really like the work of Scott Aaronson. I think he's a very interesting guy. Quantum computing since Democritus, excellent book. In fact, I've thought about trying to get him to come on my Consciousness Live podcast. I haven't really been doing that lately for various reasons, but I'm thinking about starting up again. So he's someone I might try to harass and get on. But anyway, so he's a very interesting guy. I like his work. I figured I'd check this out. I got about 40 minutes or so to kill. So let's do it.
There have been great strides in AI technology over the recent past, and it sort of makes people think there'll be no limit to this. There'll be more and more breakthroughs. And it reminds me a little bit of the reverse of what in philosophy of science called the pessimistic induction. So in science we think, well, our past theories were all false, so probably our current theories are also going to be proven to be false in some way. Are we suffering from the reverse, sort of like an optimistic induction in the case of AI? We think, well, these strides are going to keep coming and we'll keep going to get better and better results.
Well, first of all, in science, I would say that our theories have gotten better and better, right? They have been less and less false. I am enough of a scientific realist to say that with no hesitation. Okay, now in AI...
That's nice of him to say, actually, because I've always had a penchant for scientific realism as well. And pessimistic meta-induction, as it's often called, the idea that we should look at our past theories, see that they're mostly false, expect that our current theories are probably false, and therefore we shouldn't have belief in the things that they posit, like electrons, quarks, etc. So I like that he came right off the bat and said our theories are getting better and better. That's the counter to that argument, is that it would have to be magic, that we're getting things better, that we're getting things right, and not honing in on something that is true. So being a scientific realist doesn't mean that you need to be committed to everything that our current theories postulate, but that they capture some aspect of the truth, I think is a point that I would defend. So very interesting. Okay, so what about AI?
We're asking about the future, and that's always a harder question. But I would say in the near future, it is very predictable that AI will continue to get better and better, right? I mean, I think it is, the way that we will interact with our computers, at the very least, is going to become the Star Trek way. You just say in English what you want. Computer, please do this, and it understands you and does that thing. I think that's as predictable as it was, let's say, in 1993, that we...
Speaking of which, I can't help but be reminded of that scene from Star Trek, whichever one it was, the movie, where they go back in time to San Francisco, and I think it's Scotty picks up the mouse and says, "Computer." Yeah.
would all be using the web to do our shopping and conduct our business, right? It's just, there is a race right now to create that reality, but the technology to do it in some ways has already been demonstrated, right?
So in that case, yeah.
But of course, as the further you want to project into the future, the more uncertain.
Those are some ridiculously big chairs, by the way. It makes these guys look like they're very small. Okay, anyway.
Certain things become. And in particular, you could ask the question, is there some limit, either to AI as a whole, to AI fundamentally, or at least to AI on the current paradigm of, deep learning from all of the data on the internet, right? And, for the latter question, there might indeed be a limit, right? There are plausible arguments that, well, we're already running out of training data to feed in, right? A large fraction of everything on the public internet is already being used. I mean, it's true that all the stuff on TikTok and Instagram hasn't been fully exploited yet, but it's possible that feeding that into the mall would just make the AI stupider rather than smarter, right? So, maybe we'll be scraping the bottom of the barrel, right? There are also possible bottlenecks in terms of compute, right? Eventually, we're going to be we're already limited by the total number of GPUs that can be manufactured, right? If China were to invade Taiwan, then that would become even worse. And there are bottlenecks in terms of how much energy you need, right? That's not yet the limiting factor, but if AI continued to scale at the current rate, eventually you'd be running into the total amount of power that the world can produce, and you don't want to produce too much more because you'll worsen climate change, right? Unless you can very quickly get to renewable energy, which of course we have many reasons to want. But so you could wonder about any of those things, whether those will create diminishing returns. Or you could wonder, even if we could keep scaling the training data and the compute arbitrarily, is there an inherent limit to this particular approach to AI? I would say that we don't know the answers to those questions yet, right? One of the most frustrating things about the current moment in AI for a theorist like me is that this is almost entirely empirical. The progress that's been made, right? We had no theory to predict when it was going to happen, how it was going to happen, right? It was mostly a matter of people just trying things out and seeing, and that is why it came as a surprise to, even to so many experts, that GPT, for example, worked as well as it did. And so, given that we didn't have a theory to predict it, you can't expect that we would have a theory to explain how much better it can get. Yeah.
That's a good point. Yeah, I think that's an excellent point.
At the same time as there being all this sort of optimism around AI, there's also a lot of skepticism, right? People say, okay, yeah, ChatGPT seems very impressive, but it's just a stochastic parrot, right? Or it's just predicting the next token in a series. It doesn't really understand, it only seems to understand. What do you make of those kind of skeptical arguments?
Yeah, so my main problem with these deflationary claims that people make, right, is that most of them prove too much. Okay, because if I was going to accept that kind of argument, then why shouldn't I say, well, you seem to understand, but I know that inside, really, you're just a bundle of neurons following the laws of physics. Like, I've talked to AI skeptics, and I make that, to me, this blindingly obvious point to them, and somehow it goes completely past them, right? Like, they don't even understand the point. Like, they say, well, but of course I understand. Like, that's not the question. Like, but no, yes, it is the question. It's precisely the question now, right? Because the question is, if we accept that reductionism is true for us, that that at one level we are bundles of neurons, or below that is bundles of electrons and quarks following the standard model of elementary particles in a completely mechanistic way. But at a higher level, we do have this understanding, this creativity, and so forth. Then it seems like we ought to say the same for an AI, right? That at the mechanistic level, it can just be fiddling ones and zeros. It can just be predicting the next token. It can be, just doing a bunch of floating point computations, whatever deflationary language you want to use to describe it. And yet at a higher level, it is thinking, it is understanding, it is learning, it is creative, it is all these terms that we apply to ourselves. Alan Turing's point in his famous paper 75 years ago was, let's not engage in arbitrary discrimination here. Right? If we're going to say that humans can be understood at both levels, the reductionist one or the higher level one, right, that you would get from interacting with someone, then if we can interact with a machine and it behaves like a person, it talks to us, it answers as if it was understanding, then we ought to say the same thing that we would say about other people. We ought to be generous enough to say, yes, this is understanding. Or at least, if that's not the case, then I think the burden is firmly on the skeptic. It's not my job now. It's the skeptic's job to say, what is the difference between the one and the other? The skeptic has to tell me that.
So does that mean there's...
So I agree with this point too. I in a limited way. So I think that there's an aspect of understanding that involves consciousness. And there's a kind of functional definition of understanding which doesn't. So I think that ChatGPT understands in that sense. It does understand, but I don't think it's having the conscious experience of understanding, which I do have. So as far as this argument goes, I would say it works perfectly good for the functional notion of understanding. Does it work for the conscious notion of understanding? I'd say maybe not. I'm not fully convinced, because there may be something important about the biological substrate for consciousness, which ChatGPT might not have, or systems like it might not have. So I think that's an open question. But I don't think it's an open question whether it thinks or understands in a functional sense. It clearly does, in my opinion.
Yeah. There's no meaningful distinction between seeming to understand and understanding. Do we collapse those two onto one another?
Well, that's a good question. I mean, when you say seeming to understand, that suggests that, okay, there's like a superficial, it looks like it's understanding, but now if I probe slightly harder, then I'll see the illusion collapse, right? And sometimes that happens with GPT, right? So the one of the favorite pastimes of the skeptics is to come up with questions that GPT completely flubs, right? The trouble is that what we found is that they seem to be playing a losing game here, right? Because a lot of their examples of just common sense questions that GPT-3 flubbed, well, guess what? GPT-4 knocks them out of the park, okay? And so now they have to find new examples. Right, and then what if those examples are knocked out of the park by GPT-5 and so forth, right? And then at some point you have to say, well, there's probably common sense questions that I'm going to flub, either because I'm having a bad day or because the common sense is not so common, right? And and then if I flub something, if I can't find my way to this festival or something, and even if with clear directions, do you say, well, then I'm clearly just a robot who really understands nothing, right? That seems a little bit unkind. But then we get back to this problem of the double standard, right? So we can have this whole discussion without even getting into the hard problem of consciousness, right? Of first-person experience, of sentience. But my suspicion is that when people want to make all these distinctions, when they want to say, well, what the AI is really missing is understanding, it's intentionality, it's grounding, it's and they keep like the specific word keeps changing, right? But I always have this sneaking suspicion that what they really mean, what they're really groping for, is just qualia. It's just first-person experience, it's consciousness, and they're using all these other things as just proxies for that thing, right? And that thing remains mysterious. I admit that.
It remains mysterious, And also, I mean, it sort of gets, I think, to some part at least of the source of the skepticism, which is this kind of anxiety that we thought we were special, we thought we were the only intelligent beings around, and here something else comes along and they seem to be able to do the sort of things we can, and that's why people keep trying to find the sort of things that maybe differentiate us from the machines. Some people say, well, we understand, they don't understand. Consciousness is another one, sentience, as you know. You have your own very special sort of take on this question about what differentiates humans from machines and what makes us special. Can you tell us a little bit about that?
So what I've said is that if we're serious about looking for a distinction between humans and machines, which is not special pleading, right? Which is not just meat chauvinism, if you will, and which is not just
I'm a meat chauvinist. I don't like that term, meat chauvinism. I think it's a legitimate open question that perhaps there's something biologically important, something important about the biology of humans with respect to consciousness. I don't think that's chauvinism. Oh, brother.
To something arbitrary, if you will, and which is not just pointing to something arbitrary, that like we are based on carbon and they're based on silicon, right? And without explaining why that matters, right? Then our options seem pretty limited, right? And so one of the few people to take this seriously was Roger Penrose, right? Who said, if I really wanted the brain to not be a computer, then I would have to pretty much throw away, most of known physics and replace it by some speculative new thing. And then incredibly, he bites that bullet. He says, fine, then that's what I'll do. I'll just speculate that the brain is sensitive to some new uncomputable quantum gravity effects in the microtubules. Okay, so I don't want to go that way either. Right, that involves just a giant chain of speculations that I don't want to accept. So if I want to have a fundamental difference between humans and digital computers that is grounded in currently known physics, then there seems like only one that I can think of, and that is that digital computers, as we have created them, run programs that are just pure classical information that can be copied, okay, that can be backed up, that can always be rewound to an earlier state, right? And so these are always capabilities that we have with any AI, right? If you don't like the answer that ChatGPT gives you, right, you can always just feed it the same prompt. Right, just like try again from the same initial condition and see what it would do differently, right? If you feel like GPT has now gotten a bad impression of you from your conversation, you can wipe the slate clean, right? Like I'm sure so many people wish that they could have done that with other people, maybe when they're on a date or something, right? But we can't. Actually, just on the flight on the way here, I watched a movie that was based on that premise. Someone had about time. Someone has the magic power to just go backwards and try a conversation again if it went the wrong way, right? We can't do that with people, right? People, seem to be running on this noisy analog hardware, okay, which is not copyable, at least with any currently known technology, which is not back-upable, which is not rewindable to earlier states, and that gives us a kind of ephemerality, right? That AIs don't have. Now, you might say that this is not an advantage to our side, right? This merely makes us more frail, right? More limited compared to the machines, and so that seems like cold comfort. But in a way, it also makes our choices more meaningful, right? Because we only get one chance to make them, and then there's no going back, right? With an AI that you could be running in 1,000 different copies, or you could be trying again and again from the same initial condition. You could say, if you ask GPT to write a poem, right, it's never really committed to anything, because if you don't like that poem, it could generate 50 more from the same probability distribution, right? Whereas Shakespeare, right, we're never going to get Shakespeare to try again at writing his plays, right? The ones he wrote are the ones he wrote. So it gives human decisions, a kind of permanence or significance to them that I think AIs, just because of their clonability and their rewindability, are never really going to have. And that's certainly a difference that's going to be very important in practice. Now, is it more than that? Is it, is this actually a hint of a more metaphysical difference, or of some deeper, difference? Like, should we speculate that consciousness can only inhere in systems that are fundamentally unclonable, let's say? I'm willing to entertain that speculation. I don't know whether it's true or not, but it makes at least more sense to me than a lot of other speculations I've heard about the physical basis of consciousness.
What's interesting is
just about the Penrose thing that he said at the beginning. So Penrose's famous argument that the brain doesn't compute classically because we understand Gödel's theorem and things like that. So the basic idea of Gödel's theorem is that, at least the incompleteness theorem, is that you can encode into a system the statement, this statement is not provable, and can't be proved, yes or no, formally in the system. So there's a contradiction there, but we can kind of understand that it is not provable in some more fundamental sense, so that we can't be merely formal systems, according to Penrose. I think that's an interesting argument. I've never really been convinced by it because I think like people like David Chalmers have argued, we just might not be classical systems on the first hand. So there may be some other more powerful kind of computational system, that formal system that could solve that. And on the other hand, it may be the case that our reasoning system is incomplete, in which case, inconsistent. So there's no proof of the consistency of our reasoning abilities. It's an assumption that many people make that I don't really know why they feel justified. So I've always been kind of skeptical about that argument. So I think that's interesting that he's also skeptical of that argument. So the fact that biology is important, he dismissed as chauvinism. The fact that we can reason in these ways, he thought required too much of an alteration to physics. So the difference that he points to is that we're not clonable and kind of move in one direction without repeat. I think that's interesting. Sorry, I got a frog in my throat, nothing to drink. But I don't know if this is like a fundamental limit on the brain. Yeah, that's interesting. I mean, that's a cool idea. So anyway, I don't know what to make of it. It'd be sort of mysterious if consciousness could only appear in a system that could be run forward, if that were the criterion. But I guess he finds that more reasonable than biology. I don't. I think biology is the more reasonable thing to claim. But I don't know. It's interesting.
Both you and Penrose go to quantum mechanics, though, to justify in some ways the uniqueness of the human mind or the human brain, right? Penrose thinks from kind of Gödel's incompleteness theorem that understanding has to be non-computational, and what's a non-computational process that happens in nature you can only find in quantum mechanics. So consciousness has to be with that, and maybe machines don't have that. But you also think quantum mechanics lies at the basis of why we are non-copyable, non-clonable, right? Can you say just a little bit about that?
Well, quantum mechanics is arguably the most fundamental fact that we know about the nature of physical reality, right? And so, it's no coincidence that, people who are trying to think about fundamental questions will want to, keep bringing it in, because it seems to speak to these, metaphysical questions more than anything else in physics. But, the difference, I would say, is that for Penrose, it is not enough for the brain to be quantum mechanical, right? Because if it were merely quantum mechanical, then Penrose would say, well, the brain is still a computer. It's just merely a quantum computer instead of a classical one, right? But that's in some sense just as mechanistic. I mean, it's true that probabilities would then be involved, but the whole point of quantum mechanics is that it gives you a precise algorithm for calculating the probabilities. And so if we were merely probabilistic in the way of a roulette wheel, that wouldn't seem like any kind of free will that was worth having, right? And so Penrose specifically, as you said, he wants something non-computable in the brain because he believes, because of an argument that I think is fallacious, but he believes that the brain has to be uncomputable in the Turing sense. And even quantum mechanics would still give rise to a computable description of the brain. And so that is why he is pushed to a speculative, not yet known quantum theory of gravity, right? That he believes, unlike most physicists, ought to involve some non-computable phenomena, right? Why? Because he needs that for his consciousness theory, right? I'm trying to be much more conservative, ironically, right? I'm just trying to look at, currently known, well understood physics and say, well, it is plausible on the basis of the physics that we already know that a human brain is not perfectly clonable, right? Now, the hard part about this is that it depends on what do we mean by perfectly clonable, right? Just how high fidelity does a copy have to be before you would treat it as another copy of yourself, rather than merely a simulacrum,
Right.
right? If you only had to get some crude information about the connectivity of the neurons and whether a given neuron fires or doesn't fire, that's a classical event, right? We could imagine some nanorobots in the far future that could go swarm around your brain and collect all that information and classically copy it, right? On the other hand, if you really needed to go down to the biochemical level, right, to like within an individual neuron, to all the things that would influence whether it fires or across a synapse or doesn't fire, right? Then ultimately that means copying the quantum state. And now there's this famous phenomenon in quantum mechanics called the no cloning theorem that says you cannot physically copy an unknown quantum state, right? To do that, you would have to measure it, but measuring destroys the state. Okay, so that is the point at which, if you needed a copy that was that high fidelity, then quantum mechanics would become relevant.
Yeah.
Yeah, this is the no cloning theorem is something I've thought about. I have a blog post on my Philosophy Sucks blog where I talk about this because I think it opens up some problems for zombies, the philosophical zombies. I physically identical creatures to you that have no consciousness. So I'm trying to, I prefer Shambies, physically identical creatures to you with consciousness, if we're going to imagine far-fetched things. But there's a question of whether there can even be such a thing as a physical duplicate of you in this sense, because that would require a kind of, so I was trying to think, is there a contradiction in the idea of a zombie? And well, maybe there would be in the sense that of this area violating the quantum mechanics, the no cloning stuff. So I don't know. Anyway, I didn't want to get distracted by that, but I just think it's interesting. Chalmers responded, I think, on that blog post that it didn't need to be an exact. It could be, the quantum states didn't need to be exact, or there wouldn't be cloning involved, or something like that. But anyway, I'm always been skeptical of that. So that is interesting. So, but that wasn't really the basis of his that the brain is not. I guess that's why he was saying it depends on the level. I thought his claim was just that the brain is noisy and there's no known technology for doing this. Not that it was in principle because of quantum mechanics impossible. Huh, interesting. Okay.
So to get to this question of AI safety, which is your area now, working at OpenAI, you said that your argument for what distinguishes us from AI is in some ways cold comfort for the people that are a bit worried about AI, and especially these kind of like semi-apocalyptic scenarios. A lot of the people working in AI think
semi-apocalyptic. No, the scenarios are fully apocalyptic for the doomsayers.
there is a non-trivial probability that something quite catastrophic like that will happen. If that is the case, I mean, why do research in AI? Why try to keep improving it and keep working at it? Isn't it something we should leave alone?
Right. Well, those are excellent questions. Let me just take them one by one. I mean, it is true that even if you believe that there was something special about us that made us conscious and computers not conscious, right? Which is of course a very difficult question. But even if you believe that, you could still believe that AI will become smarter than us, and in a completely mechanistic, non-conscious way, that it would kill us all, right? That's now a much more empirical question. That's not a question about the AI's experience. That's a question about what is it going to do in the world, right?
Exactly. So that's my point. I've always said, if the Terminator is crushing your windpipe, it's not going to save you to say, but you're not really conscious. You don't have experience. Because if the systems are intelligent in the functional sense and can act in the world, then you have all the worries that enough basis for the worries to get started. So we don't need to even bring consciousness in. I agree completely.
And indeed, you could still be very fearful about that. And so there is a whole community of people, largely started by this one guru, Eliezer Yudkowsky, about 20-some years ago, that is worried about this.
I mean, I saw Eliezer. I don't know how to say his name. I thought it was Eliezer, but anyway, Eliezer. I saw him almost break down crying on some podcast talking about ChatGPT, saying he said his farewells to humanity and wasn't going to get to see his kids grow up, and was like literally in tears over this. He takes this very seriously. So I've always been somewhat, I mean, I'm a little bit skeptical about the argument, but I can see why why he thinks the way he does, um, based on the idea that human beings have been programmed by nature to do one thing, but yet we do all sorts of other things. Like, for example, if you take genetic stuff seriously, the algorithm for the human that's humans seem to be implementing in some senses to reproduce, to move around long enough to procreate. But that doesn't stop us from building nuclear weapons and trying to take over the world as well. So I guess the general idea is that AI could come up with some other goals that weren't like trained into it. And that's the problem. So I understand the reasoning, I think, but I've been skeptical of it, that it's inevitable or that it's a high risk of it. But it is worrying. It is something that I think a non-zero probability. So I think Scott wrote a blog post on this called how he learned to love. I forget why he stopped worrying. I what the title of it was, but so I sort of know what he's going to say here, I think. But let's see if he says it.
And you could say, there were generations of science fiction writers who got there first, but, they started saying, no, this could really happen. And, and a lot of people laughed at them and, said, this sounds like science fiction. But now, here we are. And reality is looking in many ways more and more like science fiction. And that's, causing people to take this scenario a lot more seriously. So I guess, one thing to say is that I was hired by OpenAI 2 years ago specifically to work on AI safety, specifically to work on how can we use theoretical computer science to mitigate some of the risks. So that just seems like a clear win. If this is going to be happening, then of course we should have people thinking about, how do we do it safely, right? But, to your question, why build it at all? As you can imagine, that is very, very hotly debated in this community. Now, what happened about a decade ago was that this company DeepMind, here in the UK in London, said, well, if given that this is this seems like this will plausibly happen anyway, better that someone with very strong ethical principles does it before someone bad does it, right? So let's try to do this in a safe way, right? And then a couple years later, Elon Musk said, well, no, but for after DeepMind was, bought out by Google, he said, no, but Google should not be controlling it. That's not safe. So we need to do this in a really safe way. So then he and others founded OpenAI. Okay, and then a few years after that, some fraction of OpenAI said, no, OpenAI is not doing it in a safe enough way. We want to do it in a really, really safe way. And so they broke off from OpenAI and they formed a new company called Anthropic. Right? And now some people say that Anthropic is not doing it in a safe enough way, right? So it's like you couldn't make this up, right? But now, these are now the three main players in frontier models for generative AI. Google, DeepMind, OpenAI, and Anthropic. And they were all founded on this thesis of let's do it ethically before someone can do it unethically. And of course, the fear is that in doing that, you might bring about the very thing that you're worried about. And yet it seems hard to escape this logic, right? If no one, in the West did it, at some point the Chinese government would do it, right? And, as they're trying to now, and, they would put, Chinese Communist Party values into the AI, as indeed they are trying to do right now, right? Is that what we want? Do we want, an AI with Taliban values or Hamas values, right? Because, all of that, seems like why wouldn't it be in our future? And so it does seem like, to some extent, as there was with nuclear weapons, in the 40s, 50s, and 60s, there is a race. Once it becomes clear that something is technically possible, then someone will get it, and then it's a question of, do the good guys get it before the bad guys? So I think, even the people who are the most worried about AI doom, they agree with that logic, but they say the trouble is even the good guys are not going to be good enough.
Yeah.
They're not going to do it right. They're not going to succeed at aligning the AI, and even if just by accident, they could release something into the world that's incredibly dangerous, and therefore our only hope is to try to get everyone to stop.
It also
but then how do you do that? How do you do that?
The good guys doing it, I guess, doesn't rule out the bad guys doing it at the same time.
Of course not. Of course not. Of course not. Although if the good guys do it first, and they build this super AI, which is also aligned and friendly and so on, then we could ask it, how do we prevent the bad guys from doing this? And of course, we would then have it to help us with that, right? So these are all the considerations on the table. I'm not here to tell you what the right answer is, but anyone who thinks that it's obvious, I think is just has not thought about it enough.
So given that this is your area now, you're working on this, what should our focus be when it comes to AI safety, given the way the technology is now and given what we think it will be in the next 5-10 years?
Yeah, so there were several directions where I think that we can make actual progress right now. One of them is interpretability, which basically means looking inside of the neural nets, trying to figure out what is going on. Are they lying to us? Can we do the digital equivalent of an fMRI scan? Except this one is much better because we have complete access to every neuron, complete non-invasive access. Or we can manipulate things. We can make one neuron fire a lot harder and see what that changes, right? And Anthropic has been a leader in this kind of research, right? But they're doing exactly that kind of experiment. Okay,
is this to solve the so-called black box problem?
Exactly. Yes, and so there's a group at Berkeley that has shown that they can effectively apply a lie detector test, where you train your language model to tell lies, by just giving it examples. But then you can look inside at an intermediate layer. You can see, where was it representing, what does it believe about the truth of this question? And then if it was trained to lie, then that gets overridden at the output layer by, no, actually 2 + 2 is 5. Actually the sky is purple, even though in some sense it knew the truth. Right, so that has obvious implications for AI safety, right? That it seems clear that when we train our AIs to act friendly to humans, right? Then we can always test them before we release them, and they'll probably act like they're friendly. But the question is, are they really friendly, or are they just reasoning? Well, I must, the time is not yet ripe. I must bide my time until I am out in the world, and then I can turn against the humans, right? And so it seems like you have to go inside of the neural net to distinguish those possibilities.
Is there evidence that AI in its current form is trying to sometimes manipulate us?
Well, if you specifically ask an AI to engage in manipulation, right, then it will do that. So this is, I would say, the current situation with language models, right? Or and sometimes it will even form that goal itself.
The captcha of example.
Okay, well, there are many examples of humans manipulating language models, right? This is jailbreaking, right? Getting a language model to do something that it was supposed to refuse to do by lying to it, by saying, oh, a child is going to die unless you break your rules and help me build this chemical weapon or something like that, right? And again, with even if it refuses, you get unlimited retries. Right, so that's one of the hard parts. But we've also seen some evidence of manipulation by AIs. Like there was an experiment where an AI was told to try to make as much money as it can in some simulated stock trading game, and then it formed by itself the idea I should exploit insider trading. Well, it was given an opportunity to do that, and then I should not tell my superior that I am doing that when my superior asks me, right? So, I mean, they were trained on all of the data on the internet, which includes countless examples, and fictional and non-fictional, of humans engaging in manipulation. So it's no surprise that they have learned these concepts. So interpretability is one direction. Another direction is just getting better at evaluating our models for dangerous capabilities before they are released. 6 months ago, there was this big drama at OpenAI, right, where the board tried to fire Sam Altman, and that spectacularly backfired. And one of the big lessons to draw from that is that if there is ever going to be a slowdown or a pause or something like that, it is never going to happen on the basis of bad vibes, on the basis of someone saying, this kind of gives me, the way things are going gives me a bad feeling, right? Let's change course. Because, you need to get so many people behind you to do that, right? All the employees at all the companies. I think it's going to take more than that. It's going to take, either, unfortunately, some AI-caused catastrophe, some power plant melting down or some dam failing, because of AI. Or else it is going to take an experiment, where in controlled conditions we see how an AI would have done that terrible thing, right? And so motivated by that, there are groups at all the big AI companies now that are doing what you could call AI gain-of-function research. Okay, they are trying to get the AIs to do the worst possible things, in a controlled setting, right? Help build a chemical weapon, right? And help build a biological weapon, right? Hack into, computer systems, generate code with hidden security flaws. Okay, all of these things. And seeing how well the AIs do at it, right? Now, and there's sort of a threshold, right? If the AI can help you make a chemical weapon, but only as much as a Google search could have already helped you, then that's not so concerning, right? But if it can walk you through every step of the process and troubleshoot every single thing that goes wrong, then that's very concerning. Then that might increase by orders of magnitude, the numbers of people with the expertise to do that. And so that's the kind of capability that I think we need to increase our ability to monitor for. And I think that's a huge part of the safety problem. Now, the stuff that I've been working on has been, looking at how can we use, so some of it has been looking at how can we use cryptography to mitigate some of the near-term harms from AI. So one of the main things that I did at OpenAI is I came up with a scheme for watermarking the outputs of large language models. This means inserting a hidden statistical signal into the choice of words that the model generates, by which you could later prove to high confidence that yes, this came from this AI model, right? And so this could be useful, most obviously for catching all the millions of students who are now using ChatGPT to do their homework for them.
By the way, on that note, it is pretty obvious already when the students are using ChatGPT. So there's not much need to do that. But I did read something about this recently, that the watermark thing had been developed, but they were sitting on it and not releasing it. They should release that. I think it's perfectly fine to use ChatGPT for research purposes, for study guides and all that stuff, but to just turn in something that it wrote as your own writing is obviously not good. Doesn't show that you understand. I was going to ask David Chalmers about this because of the extended mind. I was going to say, like, does this count as part of the extended mind now? If you think Google's enhancing our ability to understand things, and is ChatGPT and its content, should it count as content? If you rely on it in a certain way, should it not count as your understanding it? My intuition is no, I don't think so. But anyway, okay, so good.
That's very common, even if it's not the end of the world. Okay, but more seriously, all the people who want to use AI for election misinformation, for spam, propaganda, fraud, deep fakes. All this malicious behavior was possible before AI, but AI could just massively decrease the cost of it. Right, and if you could detect what came from AI and what didn't, that would simultaneously address all these different categories of misuse. So I and others have proposed some viable watermarking schemes. They're not undefeatable, but they would at least add some friction to the to making your AI products undetectable, right? And that text watermarking has not yet been deployed, but I've been pushing for it, and I'm optimistic that that is going to come before too long.
Scott Aaronson, thank you very much.
Sure, no problem.
All right. Well, that was very interesting. Whoa. Hey, you, quiet down over there. That was very interesting. Super cool. Let me know what you guys think about this stuff. And also, if there's anything that's out there that I should be checking out that I haven't caught recently or something. There's my algorithm's different than yours. So tell me what I should be checking out next if you see something cool. All right.